Welcome to another video and welcome to this tutorial. In this problem, we want to solve for the nature and the points of this differential equation. So to do that, I want to let this f of x comma y to be u for easier. So we have xk plus yk plus, if I expand this, we have 9x squared plus 9y squared plus 12xy. So it is very easy to determine the stationary point of this and the nature of this. So the first thing I'm going to do when giving this question is you are going to differentiate with respect to x, and doing that, so here becomes 3x raised to power 2, and this is 0, and y this is 18x plus, so this is also 0, and this is 12y because we are differentiating with respect to x, so the x here become 1. So again, we are still going to differentiate with respect to y. So we have di u over di y equals to, so we have 3y raised to power 2 plus 18y again plus 12x because we are differentiating with respect to y. So anyway, we say x, so it's 0, so it is not combined with y. And after getting this, so we are going to consider that at a turning point for this in a graph, so we have a graph for this at a turning point, so we are going to have di u di x equals to di u di y, and everything equals to 0. That is di u over di x equals to 0 and di u over di y equals to 0. So if I now let this equation above to be equals to 0, that is 3x squared plus 18x plus 12y equals to 0, and we can reduce this because 3 can go in everything. So dividing both side by 3, we have x raised to power 2 plus a is 6x plus 4y equals to 0. You call this one equation 1. And the second one can also be reduced, so which is y raised to power 2 plus 6y plus 4x equals to 0. So at this problem, it looks like simultaneous equation, but if you start letting someone so something we cannot get it, so the best thing I'm going to do is we subtract equation 2 from equation 1. Okay, so that is every equation 2 we minus it from equation 1, and by doing that, so the first term here, which is x raised to power 2, so we are going to subtract y squared from it, and the second one, which is plus 6x above, in the above, we subtract 6y from it, and we still have 4y minus 4x, everything equals to 0. So we have this as x raised to power of 2 minus y raised to power 2 plus 6x minus 4x, that becomes 2x, and minus 6y plus 4y is minus 2y, everything equals to 0. And for the first one here is a difference of the two square, which can be written as x minus y bracket, and a is x plus y. And for this, we have 2 that is common. We take out that 2 and we are left with x minus y. Everything equals to 0. So since x minus y is common at this, we factorize it out. And by doing that, we are going to have the remaining value in the bracket, which is x plus y, plus 2, which is the coefficient of x minus y at the second one. So everything equals to 0. So getting this, we can either consider x minus y equals to 0, or we consider x plus y plus 2 equals to 0, as the first one here can also be x equals to y, and y is this is x plus y equals to negative 2. So we are going to use these two different equations to test to get the value of x, and when we substitute it in any of these equations. But I'm going to consider equation 1 to obtain the real value of x. Okay, so we have x squared plus 6x plus 4y equals to 0. This is equation 1. And if you consider the first one here, we say x equals to y, that is y also equals to x. But I want to get x first. So that is anywhere we see y, we are going to replace it with x. Hereby we have x squared plus 6y plus 4x equals to 0. And here is x raised to power 2 plus 10x equals to 0. And x is common in both. By taking out x, we have this remain x plus 10 equals to 0. Therefore, we can conclude that x equals to 0 or x equals to minus 10, which is the two root for the x. And we're still going to test for the second one in this same equation for the value of x. But what we have here is x plus y equals to minus 2. I'm going to make y the subject of the formula. By doing that, we have y equals to minus 2, and we have minus x. Okay, so substituting it in this equation, we are going to have x squared plus 6x plus 4, but y here is minus 2 minus x. Okay, and everything equals to 0. The expansion of this one becomes x squared plus 6x minus 8 minus 4x equal to 0. And then we have x raised to power of 2, 6x minus 4x, that is plus 2x minus 8 equal to 0. And here is a quadratic equation where we factorize these two. Okay, so we know the middle is sum and the constant is just like product. The entire of this one becomes x plus 4 and x minus 4. You can pause this video and expand it. If you expand this, you get what we have above. Therefore, we can conclude that x equals to minus 4 and x equals to 2. So you see that we got 4 different roots for x, which means that we can still get 4 different roots for y. So I'm not going to disturb myself, so I will just consider from where we have x equals to y. Okay, so that is, if x equals to y and x equals to 0, definitely y will also become 0. Okay, and if x equals to minus 10, in this same equation, we are going to have y to be equals to minus 10. So that is for the side of when x equals to y. So for this one, again, we also have when x equals to minus 4. If you substitute it in this, we are going to have y equals to 2. And for this, if x equals to 2, we have y equals to minus 4. And which we have determined all the points. So, and if you write this in coordinate, x is 0, y is 0, x is minus 10, y is minus 10. And here is x is minus 4, y is 2, and here is x is 2, y is minus 4. All this one, we call them the critical point. Okay, we call them the critical point, and if you can't call them the critical point, we can still call them the stationary point. So here is one of the questions that we are asked to find. Okay, so we have already determined the stationary point. Okay, so to get the nature of this equation, so we know all these points above which are the stationary point. So we're going to use this important formula. So this formula is very, very important. It's what we are going to use to determine the maximum point, the minimum point, and the saddle point. So we know that this that is square u over the x that y is just like fx square, and this that is square u over the x square is fxx, and y that square u over the y square is fyy. But in the previous one, I let everything to be equals to u, just for the shortcut sake, or for easy sake for me. And here we have fs is still the u over the x. So, and if you recall, the u over the x is 3x squared plus 18x plus 12y. But we want to obtain the second derivative of this, which is fxx. If we differentiate this, we have 6x plus 18x. So we do this because of the formula that we have, that square u over the x square is one of the things that we need, which is fxx. So again, let's see along fy, which is the u over the y. So here is 3y squared plus 18y plus 12x. So you know all this one has been gotten in the previous in the above in the what's it called in the previous slide. So here we have fyy equals to, I mean, all these are the first derivative. So to obtain a second derivative, we have 6x plus 18. Okay, so we still need the square u over the x the y. All right, so which is just like fxy. And you know, this the square u over the x the y is just like di over the x bracket the u over the y. This is what it means. But if this is di over the x, and what is the u over the y that we have already gotten? So is 3y squared plus 18y plus 12. You know, it's just like fy. So which is the u the y. We are going to substitute it in this. Okay. So if you put this thing in this, which is 3x raised to power of 3y squared plus 18y plus 12x, and we still go to differentiate. Since the derivative outside is x, that we are going to differentiate with respect to x, all y becomes 0, and if you differentiate 12x is 12. Therefore the fxy equals to 12. So we are now coming back to the equation above, which is this. So because we want to use this one to determine the maximum, minimum, and the saddle point of this. So let's test for the first point at 0, comma 0. So at 0, comma 0, what are we going to obtain? So we know x is 0 here and y equals to 0. And we have changes, which is delta for this equals to, so we are going to substitute this thing in the given formula. Delta equals to fxy raised to power 2 minus fxx multiplying fyy. So getting this, what is fxy that we obtained, which is 12? So we try to replace it as 12 raised to power 2. And what is fxx? So fxx is 6 bracket 6x plus 18, and fyy is also 6y plus 18. Okay, so getting this 12 square is 144 minus, so if you try to replace x with 0, so you know 6 multiplied by 0, which is at x equal to 0, becomes 0, plus 18, that is 18. So similarly with this is also 18. Okay, so here is 144 minus, so if you try to multiply 18 and 18 together, so let's do it together. We have 18 multiplied by 18. So 18 multiplied by 18, here is 4, here is 14. So here is 8, here is 1. And everything here becomes 324. So and by trying to replace it here, we have 324. And the entire of this one becomes minus 180. So this negative 180 is less than 0. So when you are testing for this and you get negative value which is less than 0, you proceed to the second derivative, which is fxx, to check for the same point, which is at 0, comma 0. And what is the value of fxx, which is 6x plus 18? So and at x equals to 0, we have 6 into bracket of 0 plus 18, and everything here becomes 18, and 18 here is greater than 0. So if it is greater than 0, as far as you get the positive value, so it is minimum point. I mean point, minimum point. So the one I did above is, so you got negative when you put all these criteria in the formula. So as far as you get negative, which is less than 0, you try to proceed to get fxx as soon as it is negative. If it is positive, so we still have another thing to do. All right, so 18 greater than 0, which is the minimum point. So and you can still test for at negative value. So we try to plug all these values, so we have all these things. So I just don't want to waste time, so that's why I solve it already. So I will follow the same step as the examples I used above. So but you see that the letter value is still negative, which is less than 0. We also proceed to find fxx. Remember, it is fxx, not fyy, that we are going to test to determine the point. So this negative, it is a maximum. If it is negative, it's maximum, and if it is positive, it's minimum. So I will still test for this at minus 4, okay, and common 2. If x is minus 4 and y is 2, so try to substitute all this value in this. The later value is going to be positive, and positive is greater than 0. This is saddle point. Saddle point, it means there is neither maximum nor minimum. Okay, we cannot proceed to anything again, so we test for another point. So if we test for this again, it's also going to be a saddle point. Okay, so it's also going to be a saddle point. Just try to test for it using the same formula above. You get the saddle point, and then since we have two different saddle points for minus 4, 2 and 2, 4, so we neglect them, and the one that gives the maximum and the minimum point, so we are going to proceed with them. okay, to determine the nature of this equation. So we are going to consider from the real question, which is this, and we test for at 0 comma 0, which you got 0 for the first one, and then we also check for at minus 10 comma minus 10. So if you try to check for this, no, minus 10 raised to power of 3. So this one is just like minus 1000. And why this one is also minus 1000? So if you add this, that is negative 20, negative 2000. So why this is minus 10 raised to power of 2? So this one is just like odd range. And the second one is also plus odd range. So odd range plus odd, that is 200. And then multiplied by 200, that is 1800. So while for all this thing again, odd times odd range, that is 10 times 10, that is odd range, and 12 multiplied by odd range, that is going to be 1200, because negative times negative is positive, and the entire of this one becomes odd range, and odd range is greater than 0. Remember, if you are determining the values, the positive remain maximum, but if it is negative in their both in the formula, so we are going to let the negative becomes the maximum. All right. So that is how to go with this problem. Thanks for watching, and don't forget to subscribe to this channel. Never stop learning. Bye bye.